Prime factorization. Dwight has recorded 480 minutes of IBS symptoms over the last month. What is the prime factorization of 480? So, let's go over what prime factorization is. Prime factorization occurs when we divide the number into all prime numbers. There is something that we have done in the previous lessons, but we did not use the fancy term of prime factorization. One method for finding these numbers is to use a factor tree. This occurs when we split this number into two numbers that can be multiplied together to equal the number above it. So let's do the factor tree here with 480. So we would write 480 at the top, and then we would divide it by, we'll say 2 for this one. So 2 goes into 480 240 times. So if you multiply these two numbers together, they equal 480 above. So we know 2 is a prime number, so we'll just circle that number because we don't need to divide it further. Now 240, let's continue to divide this one. 240 divided by 2 is 120. So we'll circle the 2 because it's a prime number. Then we have 120, and let's divide this one. 2 into 60. We'll circle the 2. Now we have 60. 60 can be divided into 2 again. So we'll keep the 2, and we have 30 here. Then we have 30, so then we divide this by 2. You get 2 and 15. We circle the 2 because it's a prime number. Now 15 can be divided now by 3 and 5. And these both are prime numbers. So we look at this factor tree and notice how many prime numbers we have of each. So we have 1, 2, 3, 4, 5 2's. So we would have to go 2 to the 5th times this 3 times 5. And this is the prime factorization for this number. So let's look at another example, but we're going to use a different method. Example 2. Raphael knows that his IBS has been caused by stress at work. To help manage this stress, he started participating in yoga and has logged 1,890 minutes over the last 3 months. What is the prime factorization of 1,890? So the second method we're going to look at is by using a divisibility ladder. And so to use this, we're going to put 1,890, and we're going to go like this. And this is what the ladder will start out looking like. And then the number in front is going to be the number we're going to divide into, which is a prime number. So we see that there's a 0, so we're going to use a 2 first. So 2 can't go into 1, but it can go into 18. So 2 goes into 18 9 times. So we'll just put the 9 right below the 8. Now there's nothing carried over, so now 2 goes into 9 4 times. But this time 2 times 4 is 8, so we have a leftover of 1. So now 2 can go into 10 5 times. And then that's our first prime number of the 2. So we're going to do this again. Now we can see that 945 can be divided by 3 as we add up 9 plus 4 plus 5, which is then 18, and 18 is divisible by 3. So it's one of those rules that we looked at. So 3 can go into, now we'll look at the 9 3 times. nothing left over. So now we have 3 can go into 4 one time. But this time we have a 1 left over, so we carry it over to the 5, and now we have 15. So 3 goes into 15 5 times. Now let's further divide out. Now 315 can be divided by 3. So 3 can go into 3 one time. 3 can't go into 1, so we're just going to leave a 0 there and carry that 1 left over. So now 3 can go into 15 again 5 times. And then, once again, we're going to divide by 105 divided by 3. So 3 can go into 10 3 times. We'll carry that 1. Now 3 can go into 15 5 times. Now, we can no longer divide by 3, but we can look at 35. And we know that a factor is 5, as it ends in a 5. So 5 can go into 35 7 times. And so as you can see, we have all our prime numbers now on the left and this last number on the very bottom. And these are in its most reduced form. Like, these are our prime numbers. So we would then write it out as 2 times, now we have 1, 2, 3. So we have 3 3s. So we would go 3 to the 3rd power times 5 times 7. And these are all our unique factors, and they're always raised to the highest exponent to account for each one.